Welcome to Chakra International. I am Nidamarjana speaking. This is related to previous questions from engineer science preliminary. In engineer science preliminary, including the technical papers, two other papers are most important. One is engineering mathematics and is material science. Both are available in paper 1 and paper 2. That's why your audio is material science. Polymers are composed of large number of repeating units. Repeating means small molecules called monomers. Monomers are joined together end to end in a polymerization reaction. Number of repeating units in a polymer is known as degree of polymerization. Importance terms in polymers: polymerization, degree of polymerization, linear polymer, copolymers, cross-linked polymers, thermoplastic, thermoset. Polymerization, the process of linking together of monomers, is called polymerization. It is a process of growing large molecules from small ones. In polymerizations, the monomers molecules combine end to end to form a large molecule known as polymers. Degree of polymerization is the number of repeating units present in one molecule of polymer. Degree of polymerization is equal to molecular weight of a polymer divided by molecular weight of a single monomer. Linear molecular polymer, when monomers are simply added together to form a long chain, is called linear polymer. When different types of monomers are added together, it is known as copolymer. Cross-linked polymer, it is a polymer which is obtained by connecting long chains through covalent bonds. Thermoplastic, these are the linear polymers whose plasticity increases with the rise of temperature. Thermosets, these are polymers whose plasticity does not change with the increase in temperature. Property of polymers: they are low cost, fabrication can be done easily, good thermal conductivity, good electrical insulation, very high resistivity to chemical reaction, low density. Most of the polymers are organic in nature. Many organic materials are hydrocarbons. The polymers are composed of hydrogen and carbon, and their intermolecular bonds are covalent. A single covalent bond exists when each of the two bonding atoms contribute one electron for a molecule of methane. The hydrocarbon ethylene is a gas at ambient temperature and pressure has the following molecular structure. If the ethylene gas is subject to catalytically to appropriate condition of temperature and pressure, it will transform to polyethylene, which is a solid polymer material. Polymerization is the process of forming a polymer by linking monomer together. A mechanism of polymerization can divide in two types: addition polymerization, condensation polymerization. Three stages of addition polymerization: initiation, propagation, and termination. Application of addition polymerization: ethylene and polyethylene, vinyl chloride, polyvinyl chloride, propylene, polypropylene, styrene, polystyrene, methyl metacyclate, polymethyl metacyclate, tetrafluoroethylene and polytetrafluoroethylene, so on. Condensation polymerization is the formation of polymer by stepwise intermolecular chemical reaction that normally involve more than one monomer species. Condensation polymerization occurs in the combination of compound with itself or other compounds, accompanied by the elimination of some simple compounds such as water, hydrochloric acid as a result of polymerization. When phenol and formaldehyde monomers are polymerized, water is released, resulting product is called polymerized phenol, formaldehyde or bakelite. Character of condensation polymerization: like addition polymerization, various chain length can be produced, yielding a molecular weight distribution. The reaction time for the condensation is generally larger than that of addition polymerization. Condensation polymerization occurs in synthesis of thermosetting polyesters, phenol, formaldehyde, bakelite, nylons, polycarbonates. Classification of polymers: polymers can be classified in two groups: thermoplastic and thermosetting. Thermoplastic polymers consist of very long chain of carbon atoms covalently bonded together. Thermoplastic polymers become soft when heated, hard, and when cooled. When it heated and hard and when cooled. The sometimes pendant of nitrogen, oxygen, sulfur atoms, other groups of atoms are also covalently bonded. The molecular chains are bonded to each other by weak secondary bonds. These materials are normally fabricated by the simultaneous application of heat and pressure. These polymers can be reheated, reformed into new shapes many number of times without significant change in their properties. Thermoplastics are relatively soft and ductile polyvinyl chloride polystyrene used in pipe plastics doors. Thermosetting polymers. Thermosetting polymers become soft when they are heated initially, then become hard permanently upon cooling. Thermosetting polymers have a high cross-linked structure in which all the atoms are connected by strong covalent bonds. During the polymerizations, the network is completed and permanently set. Once set, additional heating does not produce softening. Hence, the thermosetting polymers cannot be reheated and reformed into new shapes. These polymers are generally stronger but are more brittle than the thermoplastic. Thermosets are highly cross-linked polymer chain that forms a three-dimensional network structure. Because the chain cannot rotate or slide, these polymers possess good strength, stiffness, and hardness. The other positive properties of polymers are high thermal stability, high dimensional stability, resistance to creep, deformation under load, lightweight, and high electrical and thermal insulation properties. These polymers have better dimensional stability. Most of the cross-linked and network polymers include vulcanized rubber, epoxies, phenolics, polysteresins. Types of polymers: commodity polymers and engineering polymers. Commodity polymers are the lightweight polymers with low strain and stiffness. Engineering polymers are designed to give improved strength, greater environmental resistance, better performance at elevated temperature, more than 350 degrees centigrade, are called engineering polymers. Commodity engineering polymers, there are many different kinds of polymers: plastic, elastomers, fibers, coatings, adhesive, foams, and films. With this, the present company like, subscribe, put a bell icon. Thank you.